All right, linear inequalities, 6-5. We're working our way up to systems of linear inequalities. And they might sound hard, but they're really easy. Do you remember how to graph a line? Ooh, I hope so. What's the difference between equality and inequality? Equality, one side or one thing or one entity will have a lot more than the other ones, right? Poor guy, he got none. This is equality. They all have the same height there. But of course, this guy can't see over us. That doesn't really matter. And this is how it... who cares? That's how political, isn't it? Equality, they're equal. Inequality, one has more. And in math, it gets to be pretty simple because we have symbols. This means equal. This means one side is more or they are not equal. There's not equal. So 4x is greater than or equal to 18. So that means x has to be greater than or equal to whatever 18 divided by 4 is, right? And the biggest difference between an equality and an inequality is that an inequality has many solutions. If this is y is less than or equal to 10, make my little dot here, every number that's less than 10, or every number that's to the left of 10, will be a solution. 0 would be a solution. 5 would be a solution. Every number between would be a solution, including decimals, fractions, everything. Any number greater than 10 would not be a solution. So there are infinite numbers of solutions to inequalities. But what if we have a two-variable expression? What if we have a y and an x? How can we show that? We can no longer put this on a number line, can we? Now we have to use a coordinate plane because we have the y and we have an x, right? Well, let's just erase that because it's not going to go along with what we got going on here. Cut. Yeah, sorry about that. Okay. Do you remember how to graph a line? Here's the y-intercept. So I'm going to go positive 10, which is right here. There's the slope, 2 over 1. Remember this? It's a positive slope. I can't go up, so I'm going to have to go down. 1, 2, left 1, because it's a positive slope. Left 1, left 1, left 1, left 1. Okay, do we have enough now that I can draw my line? Sure. Okay, and this says y is greater than or equal to. If y is greater than, and here's the y line, all the numbers that are underneath our line are less than what this y is, correct? But we only want the numbers that are greater than that y. So that means all of these ordered pairs on this side will all be solutions to this system of equations. If we want to check that, we could go to one that's not a solution, or we could go to one that is a solution and check it and see if it makes it true. Okay? So I'm going to go to 0, 0 because that's the easiest. 0, 0 should not be a solution, correct? Because it is not in the shaded part. So if I go 0 is greater than or equal to 2 times 0 plus 10. Well, 2 times 0 is 0, right? So that means I have 0 is greater than or equal to 10. And that's not true, is it? 0 is not greater than 10. And this is not part of my solution. That means I shaded the right side. It's all good. Okay, let's try this one. Y is less than or equal to negative 3 over 2x plus 2. There's the y-intercept. 1, 2. Put it right there. It's negative, so I'm going to go down 3. 1, 2, 3. And I'm going to go over 2. I'm going to go down 3 over 2. Down 3 over 2. Okay? All right, and here we have y is less than or equal to. So if it's less than, 1 is less than 2, that means it's going to be going this way, correct? Should we check it? I'm going to use 0, 0 again because I like 0, 0. It's easy. If y is 0, negative 3 over 2 times 0 plus 2. Well, this is just 0. So 0 is less than or equal to 2. Is that true? Yes. Is 0, 0 part of our solution? Yes. That means that we did indeed shade the right side. Yippee skippy. So if we went to something like 6, 0, that shouldn't work. Then we should get a false statement, right? Okay, let's try this one. There's the y-intercept. Minus 1/2, so down 1 over 2, down 1 over 2, down 1 over 2. But you see how this does not have a line under it. So this time, 1 over 2, up 1 over 2, up 1 over 2. Instead of making a straight line, I'm going to make a dashed line. That means that whatever's on this line is not part of the solution. Okay, this because whatever's on this line is not included, it wouldn't work. And y is greater than, so let's see, 3 is greater than 2, and we're hitting it at 2, so we're going to go to this side. Is this making sense? So should 0, 0 work? 0, 0 should not be a solution, correct? Let's try it. 0 is greater than, well, we know that negative 1/2 times 0 is 0, 2. Is 0 greater than 2? Nope. And it's not a solution here, so we have it shaded going the right way. Okay, last one. Y is less than x. So our y-intercept is 0. The slope is 1, right? Means the intercept is going to be right here. The slope is just going to keep going up and down all the way from here. Oops, is there a line under it? Nope, no line. So I'm going to make a dashed line. Okay, so when the line is dashed, should 0, 0 work? It should not work because 0, 0 is on the line. Is 0 less than 0? Nope, 0 is 0. So that's good. So we know we got that done right. So if y is less, are we going to shade up or are we going to shade going down? I hope you said down. So we're going to shade going down. Down is less than, right? And there we go. We could try a different ordered pair and see if it works. Should we try, let's see. Let's go 1, negative 1. So x is 1, y is negative 1. Negative 1 is less than 1. Is that true? Yes. So we know we have it going the right way. Make sense? Ready for a little practice?